Hello everyone. So today we will see why 0 factorial is equal to 1. So you all must have heard that 0 factorial is equal to 1, but have you ever thought why 0 factorial is equal to 1? So why 0 factorial is not equal to something else? So have you ever thought of proving it yourself and coming on to the conclusion that yes, 0 factorial is equal to 1, it is not equal to 0, or it is not equal to some negative number. So today we will see into some of the proofs, or I would not call it a proof, I would call it a intuitions, through which proves that 0 factorial equal to 1 makes sense. These are not a definite or a concrete proofs, that this is a mathematical proof, but these are kind of hacks which signifies that 0 factorial equal to 1. So let's get started. So what I am saying, what I am claiming is 0 factorial is equal to 1. Now I need to prove this. So we all know that if we have to find 4 factorial, what it is 4 into 3 into 2 into 1. And if I say I have to find 3 factorial, then what it is 3 into 2 into 1. And 2 factorial is 2 into 1. And 1 factorial is 1. So if we see, so if we divide this by 4, we get 3 factorial. This part, you see, 3 into 2 into 1. If we divide this by 3, we get 2 factorial. We have divided this by 4, we have divided this by 3. We will divide this by 2 to get the previous one. So we will divide it by 2 to get 1 factorial. And now we have to divide this by what number to get this? So 4, 3, 2. So we will divide it by 1. So 1 divided by 1 will be 1. So that's why 0 factorial is equal to 1. So this is just an intuition, an observation basically, which I have observed over here. And I have finally concluded that 0 factorial equal to 1. Now coming on to the little mathematical part of it, how, like why this is working. Like this is just a small example which I have took. Like if I talk in terms of n, so I know that n factorial is equal to n into n minus 1 into n minus 2 and up till so on up till 1, right? And this term, if I see this is n into n minus 1 factorial, right? I can write this n minus 1 factorial. Now n factorial equal to n into n minus 1 factorial. Now if I put n equal to 1 on both sides, so this will be 1 factorial is equal to 1 into 1 minus 1 factorial, which is further equal to 1 factorial equal to 1 into 0 factorial. And if I bring it over here, so my 0 factorial will be equal to 1 factorial divided by 1. And 1 factorial I know is 1. So 0 factorial is equal to 1. So this is another mathematical way to see through the formula how I have reached 0 factorial is equal to 1. And now I will give you one more proof, one very interesting proof of permutation formula, which is NPR. We know that NPR, what it is equal to? N factorial divided by n minus r factorial, right? So what does NPR signifies? That if we have n things, we have to arrange it. We have to pick r and then arrange it within themselves. So how many ways there will be? So let's suppose that I have one place like n equal to 1 and r equal to 1. So I have to pick one thing out of the one thing, and I have to arrange it after that. So there will be only one way for that, right? Because I have to pick one thing out of one thing. I will pick only that thing only, right? So there is only one way to pick that, and to arrange that is also one way. So if I put n1 and r1, it will be 1p1 is equal to 1 factorial divided by 1 minus 1 factorial, which is 0 factorial. And 1p1, if like if we see theoretically, like how many ways in which I can pick one object and arrange it, right? So it will be one way. So this thing will turn out to be, this thing will turn out to be 1 equal to 1 factorial divided by 0 factorial. So if I put it over here, so it will be 0 factorial is equal to 1 factorial, which is equal to 1. So here also we have proved that y 0 factorial is equal to 1. And we have one another proof, like these are small proofs. One another proof is, if I take this example of NCR. What does NCR means? That we just have to pick, we don't have to permutate, like we don't have to apply the permutation. We don't have to arrange it, we just have to pick it, and that is it, that's it. Like in the NPR, we were picking it as well as we were arranging it between themselves, but in the NCR there is no such thing, we just have to pick it. So it's a formula if we see mathematically. Like intuitively I have already explained you in the proof one, but here we are talking about the mathematical expressions. So if we see over here, so NCR, like number of ways, if I put n equal to 1 and r equal to 1, that is number of ways of picking one object out of one object. That will be 1, obviously, right? So my left hand side will be 1, and if I put it 1 factorial divided by 1 minus 1 will be 0 factorial, and r 1 factorial, right? So if I put this 0 factorial to over here, so it will be 0 factorial equal to 1 factorial divided by 1 factorial, which is equal to 1, right? So this is one another proof which tells that 0 factorial is equal to 1. So there is one last proof in which, by the definition of permutation, it is said that how many ways can we select nothing, right? So in how many ways can we select no items from a given item, right? If we have like 1, 2, 3, 4, 5, in how many ways can we select nothing out of it? So there is only one way, which is the empty set. If it is empty or null or void, like whichever set you want to call it, if that set is there, so how many ways? There is only one way. That is, there is only one set, which is null set, empty set. That's why we say that 0 factorial by theoretical means, it signifies that how many ways are there to pick that thing which has no element, to pick that set which has no element. So there is only one way, that is to pick an empty set. So that's why we say that 0 factorial is equal to 1. This is in terms of, if we don't talk about any mathematical thing, if we talk about the significance of this factorial, like what does factorial means. So this is another proof of 0 factorial equal to 1. I hope you liked the video. If you like the video, please like, subscribe, and comment on this video. Thank you.